Good morning, everybody. We're back for another live stream session. This morning we're going to go through some of the architecture we came up with and develop some documentation around that. Probably make a nice fancy diagram. I don't know if that I do that for all my projects. I think it helps a lot for people who aren't as familiar with serverless or cloud infrastructures in the beginning. You know, there's kind of a debate brewing on Twitter over the weekend about um, a a uh, a serverless architecture diagram was shared widely, and somebody was kind of flaming it because it was really complicated. I'm gonna pull that up actually because that's kind of fun. Uh, you see um, infrastructure diagrams in a more traditional environment where you have a load balancer, you have a couple front end servers, maybe an app server, these tiers, these 3 tier or 5 tier applications depending on how many caching layers or what have you. But from they're rooted in like network connectivity, and then virtual machines or hosts in your environment, and that's the extent of the physical architecture. Most architecture diagrams exclude process calls or function calls or anything else. They reserve that for other diagrams. And what serverless does is it extracts a lot of that process flow and pushes it down, up, down, depending on which perspective you have. It forces it to that. It forces that in that direction. So I think just realized I don't think my music is playing. What's going on here? Sorry, gang. Got some technical difficulties here. Yeah, it's working, and now it's not. I don't know. We're gonna have to go without music today, unless you can hear it. I don't know. If you're in the chat, let me know if you can hear the music. I don't see it on my OBS. We're gonna skip all that. Yeah, so serverless, with a serverless architecture, what it does is it extracts those process calls, basically puts an HTTP endpoint in front of it. So now everything is an HTTP call, and it then takes all of that complexity and everything and pushes it into your physical architecture. So when you spread these things out, it gets there's people who aren't used to it, and that can cause people to get a little excited. Yeah, so this is the article that kind of drew this attention over the weekend, where people were talking about the typical serverless architecture, and then this spaghetti mess of different pieces. This is what kind of blew up over the weekend, and there were kind of two camps, two groups of people who were talking about, the complexity. Like, how is this supposed to be simpler? Was a really common theme I saw, where people were asking, like, how is this supposed to be more simple than a more traditional data center hosted uh, application? Which I think it's kind of a disingenuous argument. It comes from a place of not fully understanding what the promise of serverless is. So when you're kind of misrepresenting what the promise of serverless is, it's easy to then look at something like this and say, like, wow, this is really complicated. This is really hard to understand. Because it can be, this, if you were to put this in front of somebody who's never done anything in the cloud before, yeah, this could be more complicated than people expect. But if you were to map all the calls in your infrastructure, everything from your network requests down to the host level with your process calls, it would be far more complicated than even this diagram. So you could get, pedantic kind of in the other direction and make the same argument. So it was kind of funny to watch, and ultimately not a very productive conversation, but it was kind of a weird thing to have happen over the weekend. But I think this is a really nice diagram to kind of call out all of the pieces involved. So that's what I want to make today for our little serverless record processor. This probably needs a better name. There's only two hard problems in computing, right? Cache invalidation and naming things, and off by one errors. So we went through our non-functional requirements, uh, and then from there we settled into an architecture in the README. So I think we will take this architecture and diagram out the big pieces. We will exclude a few things like the deployment infrastructure. We won't map that out. I consider that separate. We won't include. If we can get this done in a reasonable amount of time today, I'll probably start talking about failure modes, and maybe we can put some of those things in the diagram as well. Anyway, so hopping over to draw.io, I've already set it up. It's going to save into my Google Drive. It's a pretty nice web-based flowchart diagramming software. For years, people built these things in Visio or other fairly expensive software suites, and I think we saw a big rise of people who frustrated with having to spend that much money just to make a rather simple diagram. So then you see tools like this show up. Another one that I see people use is CloudCraft, I think. Yeah. So CloudCraft has this kind of isometric 3D view of your infrastructure, which, if you're trying to pitch things or really want to wow people, makes it pretty easy to build these. I haven't found these to be super useful with serverless yet. This is far more valuable if you're doing a lot of more traditional VM-based or host-based architectures. It represents auto scaling really well. It'll show you the kind of the tiers of your application. I built a few of these in I built a few serverless diagrams in this, and it was okay. I didn't. I think using this is going to be probably a little bit better. Using Drawio. I wonder if I can get both of these on the screen at the same time. Let's see. I know this is super exciting. Tune in and watch Levi fiddle with Windows on his computer. You can see the money rolling in. Okay, there. I think that'll be good enough for now. Software's pretty easy to use. Mostly just drag and drop, and then there's connection points and stuff added. It comes preloaded with a bunch of AWS icons already, so you don't really have to do a lot of configuration. You don't have to seek out icons or get them loaded. I remember years and years ago, you used to have to get the record pack from Microsoft and load it into your Visio software, and sometimes it would just forget where it was, and you'd have to reconnect it. It was super annoying. A lot of these tools come pre-configured now, so you don't really have to spend a lot of time fiddling around. Which is really nice. So, in our architecture list here, we have, this is pretty close to the general flow of the data. And I like to list things off in that way so that things are kind of logically laid out and consumable, especially for people who are unfamiliar with architecture. So our first piece is going to be some kind of connection. So the thing we laid out in the previous video was a WebSocket connection. I don't know that we have anything to represent our WebSocket, so let's just punt and we use ye old rounded rectangle for now. So you can just click it, drops it in the window, and then I'm just going to call it the WebSocket, because it doesn't really matter, right? There's, in our architecture, or in our documentation, we'll call out, or we would call out, maybe have a separate section for the WebSocket configuration, because it's an external hosted connection. So in your documentation, you would call out like configuring, getting access to it, where to test it, general things that you'd need to find if you were going to work on this. All right, so that is our external connection. Generally, I like to lay things out left to right, which is backwards, right? So left to right, because that's how English speakers read. We read from left to right, so laying out your architecture diagrams in that logical kind of default manner really helps readability. Let's see if we have a, look at that, we have a Fargate icon. Ooh, there's two different colors. So your more traditional AWS icons are this orange. So we'll probably go with that for now. So you see how it automatically starts aligning those little, I don't know if you can, little lines show up and help you align your icons. Years and years ago, I used to work for a print shop, and I spent a lot of time working with the Adobe suite. So I got really good at Illustrator specifically. For some reason, Illustrator called to me more than Photoshop did. I liked the objects and the layers and the kind of working in vector format. So a lot of the diagramming applications are intuitive to me because of the how similar it is to working in Illustrator. You see around the edges of these icons, I don't. It comes configured. So if you know, like this, our rounded rectangle here has a bunch of little anchor points, and if you click on it, you can easily drag connections. And then there's those blue arrows too. I think they're blue. See, you can just click on it and start dragging, and then get your flow going. You know, your network or your process flow going pretty quickly. So we're going to call this the Fargate. The Fargate client. All right, so there we have our first piece. Congratulations. That Fargate client will then consume those records and put them on a queue. Ooh. Okay, I'm gonna second guess myself here. I'm starting to like these icons better. There they are. There we go. So that's connected. We got this guy going over here. There we go. So, I wonder if I can change the label on this. Yep. It's so hard. If you are of a certain age, you may remember a TV show called Aqua Teen Hunger Force, which was on Adult Swim, and it was terrible. But we also enjoyed, some friends of mine and I enjoyed the stupid quips and other things they would say. And there was one episode where they were ripping off the Stargate concept, and they called it the Fargate. So now, whenever I see Fargate written down, or whenever I talk about it, I always hear the voice of that character, and makes me laugh. So, in life, it's important to be able to make yourself laugh, especially if no one else can. In a really sophisticated architecture diagram, you'd be able to link these individual pieces out, and we'll see if we can do that. Maybe, I don't think this diagram will be interactive enough to have links on each piece, because we're just gonna, I think I'm just gonna generate this and dump it out into our repo. But if you're building this in, I've seen some Confluence plugins and other things have links out from your repo, or not from your diagram, so you can link individual pieces, and depending on how you have that diagrammed or defined, maybe it links out to code or could link out to a separate Confluence article describing that individual piece. I don't think we're going to have anything that sophisticated here, but it's a thing to think about. It's really nice to be able to hyperlink all of your things together and make your documentation much more interactive and much quicker to explore. So there we go. We have our queue, and then we're going to do a Lambda function. Set that blue. There we go. Why is that so much bigger than... Oh, it's not bigger. It's just the label. What the heck? There we go. That's too small. Yeah, I don't like how small that is. So let's get it back up to 10. What? Oh, there we go. Okay. We're all on super clever naming here today. So we have our... I don't know if there's anything really particular to call out for the queue itself. Then we have the queue processor. So I'm just adding icons right now, but we'll add more things and we'll lay it out in a bit. So again, run out of space here, and you can extend the diagram, but I don't necessarily. Ooh, magic button, landscape. There. Now I've extended the diagram. I don't know what this boat icon is for, but now I definitely want to use it. If you're in school or early in your career, I highly recommend you learn at least the basics of process diagramming. All of these shapes have a meaning in a more traditional or structured diagramming methodology. I never took the time to learn it, so I have to constantly look up what the shapes are and what they mean. There's an extra layer of there's additional context and other information being conveyed when you use these shapes and you understand what they mean. So I highly recommend at least learn the basics, learn what the shapes mean and how to convey that information to your consumers. Ooh, I like this arrow. We're going to use... So I'm looking for a different icon to represent the stream of data coming out of off the Dynamo table, because I want to convey that in my diagram. Whereas these other services call, Fargate, the client running in Fargate will call the SQS API. Maybe here from SQS to Lambda, I might change the icons or the line that goes between the two to call out that there's a trigger on the queue that triggers the Lambda processor. But the Lambda processor will call the DynamoDB API. I try to keep those things consistent just for future's sake, for readability, for to quickly understand the diagram that you're putting together here. Yeah, I don't know if I like this icon, but we're gonna roll with it just in case. Okay, and then we have our sort of final destination for our records. So the general flow of this, I don't like this. There we go. So that's the general flow of our data in our serverless processor. There will be calls between this, let me rephrase it, this function, this SQS processor. There will be a bunch of reads that happen against the Dynamo table to pull the previously processed records, do the analysis comparison, and then write the final record there. And then the table will be configured with a stream that goes to a Lambda function, and then those changed records will be written to S3 for long-term storage, for ingestion into future systems. So if you want to do more analysis on this stuff, if you want to dive deeper into those records, probably use something like Athena to do querying and reporting on it. There are a few services you could layer on top of that, but we can add those in later as long as we have a persistent data destination. We can hook most things up to that. And if we can't, then I don't know, maybe we'll have to pivot and figure out how to ingest those records into a reporting system. So if you want to ship these off, maybe you have some kind of data science team or data management team somewhere in your organization, and they provide infrastructure for you. You could easily fork the flow here, so go to S3 plus somewhere else. You could do some other flow here. If you didn't want to do that, you could get super fancy and have a bucket trigger on this S3 bucket that every time a object is stored in that bucket, it also gets pushed to the destination. So if they have a reporting server, some kind of stack or something that they provide to the organization. And then if you have external sources, if you have Splunk, or Splunk's not a good example, but something more like more query based or records based, you could ship it off. I guess you probably could use Splunk, but that wouldn't be my choice. It's more for log messages and stuff. If you have a Elasticsearch cluster that somebody maintains, you could ship these records off to an index in there. Ideally, it would be really nice if they had APIs and stuff that you could interact with. And and ship your records off, or they would subscribe to your bucket, or there's lots of ways depending on how your organization is configured, how things are, how teams are aligned, or kind of what's going on in your org. DynamoDB stream. Okay, so we're calling that out. We got the stream going. This would be the I don't know, what do we call this thing? Did I have a name for it over here? Stream to Lambda. Super descriptive. Good job. And then it doesn't fit. Half of the time you spend on your architecture diagrams will just be trying to get things to fit properly into the window. It's not gonna work. No, it doesn't work. Why? Okay, I'm giving up. Okay, that is essentially our architecture. So now that we have it laid out in kind of a diagram, you can start looking at the different pieces and start to understand where you would maybe draw service boundaries, or at least deployment boundaries. So which pieces can you which pieces can you deploy together? I start mapping those things out so that I understand where I can, how to write my CloudFormation when I'm defining an infrastructure. Like where do I want to put these things together in stacks so that it's easy to iterate and I don't have to wait for 10 forevers while CloudFormation decides to, reconcile its internal state. So the static parts of this thing are definitely going to be the S3 bucket. Like those, once you deploy a bucket, they rarely change. You may add bucket policies around security features, so you may encrypt the bucket, you may prevent people from creating public objects or turning on hosting or whatever. Those are small changes that can come to the bucket afterwards. So that's a really static part. I suspect that we will have, the queue will be relatively static. I'm not sure which is a simpler CloudFormation definition, an S3 bucket or a queue. It might be a contest worth exploring. Like which is fewer lines, because they're both really, really simple to write. I expect a lot of iteration on this processor that reads from the queue and reads from Dynamo, does the analysis on our records, and then writes it out. And there'll probably be some iteration on the stream processor as well. Not as much as the queue processor, because that's where most of the business logic of this service will live, is here in kind of the queue processor. That's where all the value is going to be, because that's what looks into the records coming in. That's what's making decisions and recommendations or whatever this thing does. So we'll probably have a lot of iteration on that part. So I would say making that a small piece is a good idea. Let's draw some boundaries here so that we can advance shapes. Let's see, what can we use for... So just making a regular rectangle here. Let's do dashed line, because everybody knows that dashed lines are where it's at. We're going to give it transparent background, because that way when we drag it over or around our objects, we don't cover it up. I think from a deployment perspective, this Fargate client is going to live on its own. There's more than just a container here. There's going to be a bunch of resources that we have to create. You'll need an ECS cluster. You'll need task definition, service definition. There'll be roles. There may be auto-scaling rules. There's a bunch of things that will live in this service boundary. Is there an easy way to duplicate? Yes. Yes, there is. Okay, so then I think the next area would probably be here. Showing up really nice. Okay. So dependencies between stacks can be challenging to navigate. So whenever you have tight dependencies, it's really nice to deploy those things in the same stack. Then the references in the stack will resolve your dependency chain and deploy them out in the right order. So because of that, so we're going to have a dependency between this Lambda function and the queue. Actually, we won't. What we'll have is another resource in between here that's a trigger. That trigger will have a dependency on the queue. The Lambda processing function itself won't interact with the queue, so it won't need to know the name of the queue. It won't need to know anything about it, because those records are going to be read from the queue as a batch, and that batch is sent to, this is kind of what the trigger does. The trigger will read those messages and then invoke the Lambda with that event as the payload, or those messages as the event payload. So the processor itself doesn't have, the actual Lambda function doesn't have a dependency on the queue, but the trigger that invokes that Lambda will have that dependency. So you might, I don't know, we'll get into how we resolve that a little bit later, probably when we start writing the code here. But I still consider this kind of a service boundary. There will be a tight dependency between the processor and the database, so maybe it makes sense to include that database in this boundary. This is where I start to hesitate a little bit, because if we're going to be iterating a lot on this processing function, including the table, including the Dynamo table in that CloudFormation can slow it down. Generally, you shouldn't have any changes to your table once it's defined. but at the same time, still kind of worried about that. Kind of worried about that being an issue. So, another pattern I've seen for defining your infrastructure is to do. So this is we're going to consider this all one service, a single service, because nothing else should be reading or writing from these queues or this table. Maybe this bucket. The bucket might be a kind of an interface between this service and other things. So if we define it all as one service, we say that nothing else should be reading or writing from these things. Then I will take your data layer items and deploy those as all as one stack. So your bucket, your table, and your queue all kind of they hold state and they persist data. So deploying those out as a layer of your service is generally a pretty successful pattern too. So I think that's probably how we are going to do this. So rather than drawing these service boundaries, we'll probably just say, the bucket, the table, and the queue will be deployed as one stack. And then we can use CloudFormation. So either outputs or exports from the stack. So when the CloudFormation stack role deploys out, there are outputs on that stack, and then we can use those outputs in as inputs into further stacks. So if we want to make a really bad diagram of this, these pieces live down here, kind of our data layer, and then we'll have these calls kind of. Ooh, I wonder if I can make this look even worse. Yes, I can. So I'm only organizing this diagram in this manner just to illustrate a point. This is not how I would recommend you actually leave this. But everything down here, yeah. This is our data layer. This is where information lives long term. And then everything up here should be kind of a ephemeral and as stateless as possible. And then probably deploy things in that manner. So I think if I were to organize my CloudFormation, I'd probably put that in a stack. Whoa, look at that. Probably put this Fargate container in a stack. Because like I said, there's going to be more than just a container in this template. There's going to be you need an ECS cluster, which sounds daunting, but that's actually just a few lines. It's just a logical collection of containers running. It's not until you start adding autoscaling groups and self-hosted nodes that it gets complicated. Might have this function as its own stack because there's going to be a lot of iteration there. And then maybe we'll just sneak these two things into their own stack. And let's just make it really ugly. There we go. So I think that's how we'll organize the resources. This thing's shared, saved. We'll just call that the Serverless Record Processor. Look at that, fancy. Save. So I've got about 15 minutes left or so. Whenever Lambda function whenever it fails, whenever there's a failed invocation, you can take that that event that caused it to fail, or the event that was fed to it when it failed, and you can shuffle that off to some other destination. So maybe you don't have a reliable invocation schema. Maybe you have all kinds of data coming in from all different places. So you could take those records and then evaluate them and do some analysis on them and figure out why your Lambda function failed on those particular events. And we will definitely need something like that here in our architecture, because we're going to be operating at a high volume at the front end here. If you think about 6,000 messages per minute, that's probably not a lot of data. Like just raw bytes. It's not actually a lot. But each one of those messages is an event, or could potentially be an event. And that means there could be a lot of things that somebody on your, maybe, whoever's building this architecture, whoever's building this service inside your org, if you have a lot of failures in one day, or if this thing just kind of goes sideways, there could be a lot of things that a human being has to dig through and figure out, like, why are they failing. So we will configure the dead letter queue of this processor, and it'll have to go somewhere. I don't know what we'll do with it. Probably send it to an S3 bucket for now, I think. This is where the documentation starts to fail me. I shouldn't say the documentation, I should say my brain. My brain starts to fail me. See, 2016. These things are really new. Usually what I like to do is look at the CloudFormation. For the properties or how to configure a given resource, and that generally tells me what I need to do for. It gives me an idea of, like, all of the things you can do, or all the ways you can configure a given resource. So dead letter queue looks really simple. It's just a just a target ARN. So super simple. It looks like we only have 2 destinations for a dead letter queue. So you can do an SNS topic or an actual queue, SQSQ. It really comes down to like how do we want to handle this. I think we'll put them in a queue for now, and then maybe I don't know. I'm trying to decide if we want to write these things into S3 and then do some offline analysis. You know, pull those objects down onto your laptop, or do some local analysis of why they failed. Or if we want to push them into like a CloudWatch log group and then use the parsing and search options in CloudWatch Insights to dig up like why these things are failing. I think an S3 bucket will probably be better long term, because not only can we use maybe, you know, especially if you have a team who has existing tool sets that they like, you know, if they're really good with bash, you know, command line tools, if they're good with grep and regex and other stuff on their local machine, then the S3 bucket makes sense to me, because you can pull those things down and do some analysis on it with tools you're familiar with. I also like it because you can then take those objects and invoke your lambdas with those payloads. You know, maybe you've got the Python, you know, we're going to be using Python for this. So maybe you've got the Python running locally, and you can then feed them into that function locally and figure out what the heck's going on. That helps you understand how you want to consume those things, how you want to use those records. It should inform your architecture. So spending some time thinking about that helps here. So we will do there we go. So now we've added kind of an error handling path. If we want to go straight to S3, probably want to do they introduced this thing called Destinations, Lambda Destinations last year. I haven't done enough digging into it. It seems like it's kind of a wider array of places you can send events on a successful or on a failure. Okay, so Lambda Destinations allows you to kind of determine if a Lambda succeeds, you know, send the output or send the data to one destination. If it fails, send it to a different destination. So you can start doing some flow, some logic flow in your function calls. So at first glance, most people will be like, hey, this is kind of cool. And I mostly agree. But it takes some of the complexity of your application and hides it in your infrastructure. And if you have a team of people who aren't used to looking for logic there, who aren't used to looking for events that happen outside of the application code, then you could end up with longer troubleshooting cycles, and you could end up with people not understanding the the way that things get invoked or the way that things happen. So I think you need to be thoughtful using things like this. Previously, I've been on teams where we made rules that you'd more so in kind of the relational database world, like we refuse to use any database triggers. So we did one table early on in the application development that had some triggers, and it had some logic built into the table rather than our app code. And it kind of bit us because it was hard to communicate that values in your table were being calculated after you would write it, or yeah, I don't know, there were some issues. So I think it's just important to always remember where you want your logic to live, and make sure that you're documenting these things well. All right, I think that is going to be the architecture diagram for now. We'll probably evolve these things over the course of our development, but this will grow. This will evolve. The more visually inclined people out there, you may say, I want to use these graphics or these things, whatever. There's lots of ways you can probably improve this diagram. Like I said earlier, I would love to have links between all of these pieces to the CloudFormation, or to those things living in GitLab. But we don't have that on our project, so we'll see how that goes. Anyway, I need to get to work. I would love to sit here and chat with you all, but gotta go pay the bills. So if you enjoyed this, let me know. Hit me up on Twitter, drop me a comment here. I appreciate it, and I'll see you soon.